Oh, sorry about that. Oh, hey there, fourth grade. I was just working on one of my builds for Minecraft. And ironically, it kind of reminds me about what we're going to be doing next in art class that goes along with our theme for this trimester, which is form and function. Form and function, and actually Minecraft, has to do with our next unit, which is CAD. CAD stands for Computer Aided Design. Computer Aided Design is what engineers are using to replace traditional blueprints for creating different objects these days, and for using to create architectural structures. And those are the original blueprints that they would have used to manufacture products. When I think of CAD, CAD is what you can use to create, like I said, architectural designs. You can use for building floor plans. You can use for electrical schematics, mechanical drawings, different technical drawings. They're used for even like the special effects that you see in a lot of like the TV shows and the movies that you guys watch these days. But how does this exactly relate to the Minecraft that I was playing? When I think of Minecraft, Minecraft is kind of like the gateway CAD program. So I know you're sitting there thinking, oh man, Mrs. Lukes is actually promoting for me to play Minecraft at home. Kind of, in a sense that Minecraft is, it's kind of like the building blocks to CAD program, in a sense that yes, you are looking at the schematics of building this particular world that you're working on. It is a blueprint. You are able to create this world. And what is this actual connection to how are these blueprints transferring to how engineers are actually building and creating products today? So to understand this link between this Minecraft world that you guys are creating at home and these CAD type design programs that engineers are using to create their products, what we need to do first is we need to understand how CAD programs work. So what we're going to do is we're going to watch a video about how CAD programs work and to help us understand CAD designing. And then we are actually going to be working on a CAD type design product ourselves. So stay tuned. We'll get back. We'll learn a little bit more about Minecraft, a little bit about architecture, a little bit about installation, and do a little bit of creating of our own. So see you soon.
Welcome, FMS, to the wonderful world of CAD. How exciting! What the heck is CAD? I have no idea. Trust me, you're gonna love working with CAD. Everything all around us, everything that's been built in the last 30 years, 40 years, has been built with CAD. Well, Mr. Corbett, that's fantastic, but I still have no idea what CAD is. What is CAD?
Tech time with Mr. Corbett. CAD stands for Computer Aided Drawing. It's when you use the computer to draw some stuff. And then that gets used in manufacturing.
That's right, CAD has been used in manufacturing over the last 40 years.
And manufacturing is the making of things. It could be anything. Let's take a look at some examples of CAD, Computer Aided Drawing.
Here we see Tinkercad, which you'll be using soon. Now that you know what CAD is, let's take a brief tour through some of the professions that use CAD. Structural engineers use CAD to see how strong buildings and bridges are. They can test the strength of a material seen here to see how strong it is before they build something out of it. Biomedical engineers develop everything from life-saving ventilators to CAT scan machines to hospital furniture to prosthetics shown here or medical implants such as pacemakers and artificial heart valves. Electrical engineers use CAD to design computer components which are used in everything that has a computer, such as your phone, car, refrigerator, TV, and smart device, just to name a few. The circuit is designed with wires and components, and then it can be manufactured and installed in any of these devices. Aerospace engineering is the building of things that fly through the air or space. Using CAD, an airplane wing can be designed and tested on the computer to see how the air will flow over the wing. Engineers can determine how a plane will react to different variables such as ice, snow, or turbulence without endangering people. CAD is used by NASA to design all components for the International Space Station and spaceflight. Visual effects artists use computer-generated imagery, or CGI, to create images for movies, video games, television, and simulations. These visual effects artists use a variety of CAD programs to achieve this. Live-action scenes with real people are combined with CGI to create these action sequences. Here we see a fight scene on top of an airplane in Spider-Man Homecoming, and you can see the CAD models. Visual effects artists also create models, graphics, and worlds for video games. Here we see Spark from Fortnite, and she moves like a real human. In CAD, the artist creates parameters so her body can move and twist just like a real human. Different skins or outfits can be downloaded and applied to the model to make all players unique. Industrial designers develop how all our products look, feel, and interact with us. Even something as simple as a shampoo bottle has to be designed in CAD so it can be manufactured and hold the product inside. I use CAD all the time to build things. Here's a door I designed with CAD, and with the click of a button, I have all the measurements so I can build this in my shop. An interior designer would use CAD to lay out spaces inside of a building. They could show the owner of the space different designs so they know what it's going to look like before committing to buying the materials and furniture. Here's my bathroom, and when visitors come visit, they will find this huge doorway into a bedroom, which leaves little privacy. Here's the door I designed in CAD, and I can close that door, giving guests their privacy when using the bathroom. This easily rolls on a track that was designed in CAD, and it even has real portholes off of a ship. How cool is that? A furniture designer can use CAD to create plans for kitchen cabinets, chairs, tables, or here we have a TV stand. After designing this, I was able to make it in my shop by following the CAD plans, and it holds the TV, Wii, DVD player, and stereo. Has anyone seen Frank? Oh, there he is. I was wondering where Frank went. Here I use CAD to design my new deck, as my old one was rotting away. I'm able to color code all the different size components, so when I go to the lumber store, I know exactly what materials to buy. An architect would use CAD to show clients what the building will look like. Architects use CAD to design buildings ranging from residential homes, to malls, to huge skyscrapers. And using CAD, I was able to see how my new deck was going to look and make sure the stairs were going to reach the patio before I built it. The final product looks very similar to my original design. What do you think? Besides architects, structural engineers use CAD to ensure a building is strong enough to stand the elements. Here's my design for the shop I built. I drew it in CAD and then gave my plans to a structural engineer. They reviewed the plans and determined the building was strong enough to withstand wind, snow, and other forces. Working with my family, I started to construct the building. Here I am laying blocks that will be the foundation. In my CAD drawing, you saw all the studs shown here making up the walls. Then sheathing was added to the walls and the roof rafters installed. The final steps involved putting on the siding and running the electrical inside to power all the lights and the tools. Careers that use CAD often overlap. Let's put together all we have learned about CAD into one big project. As an interior designer, I created a mantle for my fireplace that has a hidden secret. By drawing it in CAD, I'm able to see what the finished product will look like before I make it. I drew it in CAD and then color-coded all the different size pieces. This way I knew how many of each piece I would need. When I printed out the CAD drawing, it made it easy to cut all the wood pieces. Here you can see the many parts that I had to make. As a furniture maker, I got to work using the table saw to cut strips of wood. I knew exactly how big to make each piece, referencing the CAD drawings as I cut them to length. Before assembling, I sanded all the parts. Remember doing that sanding in 6th grade on the buck saw handles? Ugh. Next, it was on to manufacturing, as we glued and screwed the pieces together. Just like you did on your catapult, I drilled a small hole first and then installed the screw. Here we can see it taking shape, which looks just like the CAD drawing. These motors were planned out and wired up just like an electrical engineer would design. I wrote code to control the motors with the TV remote control. This is similar to the coding and programming that you did with Scratch. Press a button, and a tiny computer receives a signal and sends power to the motors that open the doors. Finally, some paint and it's done. When I want to watch a movie, just press a button and the speakers can be used. When the movie's over, they are hidden away. This project used CAD and skills that engineers use every day.
So when I make all my videos, I use this microphone here on top of my camera, and I have a mount for it, snapped right in. Problem is, it fell over one day, and you can see that this thing's broken. Look at that. All right. So what I did was, in CAD over here, I redesigned the piece. Let's take a look. We'll zoom in. All right, look at the side here. You can see how thin this piece is? So what I did was I made this one really thick. You see how thick that is? So hopefully if it falls over, it'll be a lot stronger. Okay, so let's print this. We're gonna zoom out here and get everything all set up. Right there. We're gonna press Control P, and I'm just gonna grab it. And there it is. Whoops, 3D printed piece. All right, look at that. So it snaps right in, and now I have a new microphone holder. Totally awesome. All right, oh, I'm just kidding. I 3D printed it. Let's see what this really got printed on. So I'm just kidding. We got these 3D printers, and what you do is you draw what you want to make in CAD, and then you can put it on the printer, and then the printer will print out layer by layer what you make. So that's how I made this piece. It was 3D printed on here. Here's some head pieces. A transparent sheet. Look at that. Now you have a face shield that you can give to a medical worker, and that'll help protect them when they're working with people that have the coronavirus. Well, hello students. Thanks for joining me on this wonderful journey learning all about CAD, computer-aided drawings. I hope you realize that it's got a wide variety of applications, from structural engineers to architecture to video game design and movies. I want you to...
Hi, fourth grade. It's Mrs. Lukes. After you download Tinkercad from the student portal, it is going to take you to a page that looks like this. You're going to have two options when you start Tinkercad. Option one is you are going to be able to join a class that your teacher sets up for you. And option two is you're going to be able to create a personal account. Your teacher is going to advise you which option they want you to do, whether it's joining a class or creating a personal account. If you create a personal account, you're going to be using your DG ID number to do this. So that is your DG number at students.dg58.org. That's your email address that you would sign in and use your regular password. So if I click on that blue link, it will take me to this screen. So what you're going to use then is that sign in with Google, not sign up with email, not sign in with Apple. That's that middle one here that says sign in with Google. So that's your Google ID that you have through the district. So when I click on that, it might ask you to type all that in. So again, that's your DG number. That's your DG like 018, whatever that number is, at DG58, at students.dg58.org, and then you would type in your password. So I'm going to click that. If you are already logged in on your iPad, it might take you directly into Tinkercad. Otherwise, you might have to type it in. So if I click there, it's now loading. And it looks like it's going to take me directly into Tinkercad. So now it's taking me into my desktop here. So once in Tinkercad, if you want to play for this week, you can. We're not going to be designing in Tinkercad for a couple more weeks because we have to do some sketching on paper first. But if you do want to play around, here it says create new design. If I click here on this blue create new design, this takes me to my workspace. And in my workspace here, over on the right hand side, you're going to see some of those 3D shapes that we're going to use to create our designs in a couple of weeks. So when you're looking at these are some of the shapes that we're going to work with. For this week, we're actually going to start learning how to draw some of those shapes on paper. So you might want to familiarize yourself with these in particular, especially the box, the cylinder, the sphere, the roof, the cone, the rounded roof, the wedge, the pyramid, the half sphere. We're not going to get too much into like the polygon and some of those other shapes that are down below. That doesn't mean that you can't try those, but at the same time, we're going to stick to some of the more basic shapes. You're going to find that it's going to be easier to create your design with some of these basics. As the weeks go on, though, if we get a little bit more proficient with this app, meaning if we get a little bit more experienced with the app, we can try some of the harder shapes. But for right now, we're going to stick with some of the basics. But if you'd like to play, you are welcome to play and to drag some of these into your workspace and to kind of move them around and try some different things with them. But at the same time, we'll be going over this in the next couple weeks. But feel free to play.
And we will be working though on paper this week and next week.
Oh, whoops, sorry about that. You guys caught me again. I was just working on my Minecraft. Now that we know how to get Tinkercad, what we're gonna do is we're gonna hop over to Seesaw, and I'm gonna show you guys a quick time lapse on how to draw those 3D forms that I want you to work on this week. And you will upload those into your Seesaw onto the template. And then if you have any special Minecraft builds that you did on your own, you can upload those as a bonus activity. And there's some special edition Minecraft builds that some friends have shared with us that you guys might want to take a look at. So enjoy, can't wait to see what you guys produce. And we'll see you next week for part 2 of Form and Function and learning about CAD. See you guys. In Seesaw, you will find on the template, there are several things you need to do. One, you need to upload a photo of your 3D forms. So on this page, you should have a drawing of your box, cylinder, roof, cone, rounded roof, pyramid, sphere, and half sphere. There is an example over here on the side that I did the video of, and here is the photo for you to use as reference. On page 2, this is just to remind you that you need to download Tinkercad. At the bottom it says, I was able to install Tinkercad. Please circle yes or no. If the answer is no, go ahead and fill out a help desk ticket so that way the technology department can help install Tinkercad for you. On page 3, this is the bonus activity. Please use the next page to upload any Minecraft builds that you might have made. Also check out some of these awesome creative creations that students have made as inspiration for you. And then on page 4, if you'd like to upload some optional Minecraft creations, you want to add those here. Have fun, happy creating, and we'll see you next week.